Hi guys, hope you guys had a good weekend. It was lovely around here. The rain was great and we just kind of hung out. I did some reading and hopefully you had a great time too. Did a lot of walking on Saturday. It was very nice. So hopefully you got to get out and enjoy some nice weekend fresh air. So let's get to math. All right, lesson 92. You have already done your problem solving, right? You have it there on your whiteboard. So let's talk about what our problem solving was for today. It gave us 5 terms, and remember, a term is a number that we use, a number or a letter that's in either an expression or an equation. And we've talked about equations a lot. An equation is a number sentence, like if it's 1 plus 1 equals 2. This is an equation because what makes it an equation is the equal sign, right? Okay, so we've also talked about what an expression is. So an expression is the parts that are on this side of the equation that has a mathematical operation in it. So it's 2 numbers. Like if we just had 1 plus 1, that would be an expression. It's not an equation because it doesn't have an equal sign. So you have the whole thing is an equation. When you have a number with a mathematical property without an equal sign, it's an expression. And then each of these individual numbers are terms. All of these are terms that make up the equation or the expression. So that's why in your problem solving it said you had 5 terms, 1, 2, 4, 8, and 16. Okay, they're not an expression, they're not an equation, but they are a mathematical problem for us to solve, and they're terms, and they're in a pattern. And so the problem for us to solve today is, what is the pattern? Okay, so we need to do 2 things. So the first thing that they're asking us to do is to estimate about how many terms are we going to have before we reach, 500? I think it's 500 or greater. How many terms do you think we'll have in total? So we're going to count these 5. How many more do you think we will need to have before it'll get to 500? And hopefully you'll see what this pattern does. So first of all, I think the biggest thing for us to do, let's figure out what is the pattern. When we go from 1 to 2, what did we do? We added 1, right? Okay. From 2 to 4, what did we do? We added 2. From 4 to 8, what did we do? We added 4. Okay, so if we added 4, that's not really a pattern. 1, 2, 4. What can we do to 2 to get 1? What can we do to 4 to get 2? What can we do with 8 to get 4? There's a pattern. If we multiply all the terms by 2, if we multiply the term before by 2, we get the next term. So 1 times 2 is 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. Okay. So now before we solve out what all the other terms are, we're supposed to estimate about how many terms we think it will take us to get to 500. Okay, if every term doubles, 1, 2, 3, 4, 5, that'd be about 30, 60, 120. I'm going to say about 11 terms. What did you guys say? I'm going to guess 11. All right, so to solve this, I'm going to say my estimate is 11 terms. So since I know the pattern, let's go ahead and solve it. 1, 2, 4, 8, 16. So 16 times 2 is 32. And 32 times 2 is 64. And 64 times 2 is 128. And 128 times 2 is 256. Look how quickly this gets big. 256 by 2 is 512. So there's 500. How many terms do we have? Let's see how close my estimate is. 1, 2, 3, 4, 5, 6, 7, 8, 9. So 9 terms. Did I do that correctly? Oh, well, no, because 256 is my 9th term, then this would be my 10th term here. Okay, so it took 10 terms to get to 500. 9 was only 256. So it was 10 terms, so I was pretty close. I said 11 terms. How many terms did you say? Did you get that close? That was kind of fun. So now we had to use some of our estimating skills, and we had to use some of our multiplication skills, and we had to use a pattern. And once we found what the pattern was, we had to extend a pattern. We had to keep extending it to get to 500 or greater, which was what we were wanting to know, how many terms that would take. So it didn't take long, 10 terms. If you started with 1, you only had to multiply it 10 times to get to 500. That's pretty quick. Pretty quick. Okay, and then to check it, did you use all your terms? Did you find the pattern? I think we did all those things. So, all right, you can erase your boards from your problem solving. Today, we're going to talk about classifying quadrilaterals. And we've talked about quadrilaterals before in class. We've talked about certain particular kinds of quadrilaterals. And remember what a quadrilateral means. Again, you know, in math, we talk about a lot of Latin in math. So quad, this quad means 4, and lateral, sides, 4 sides. So a quadrilateral is a shape, a flat shape, 2-dimensional, means it just has length and width. A 2-dimensional shape that has 4 sides is a quadrilateral. So any shape, if it looks like this, well, this has to be closed, right? Let me see if I can make one that's closed. 1, 2, 3, 4. 1, 2, 3, 4. 1, 2, 3, 4. Okay? So all of those shapes are quadrilaterals because the only thing it has to have is 4 sides, 4 straight sides, and they have to be closed. Okay, so we've talked about some particular kinds of quadrilaterals, and the ones that we have really discussed a lot are rectangles and squares. So, are all rectangles quadrilaterals? Yes. Are all squares quadrilaterals? Yes. So if we were going to do a Venn diagram, how about we spell it right? Quadrilaterals, we would have rectangles and squares. Guess what? There's more than just rectangles and squares. And we've kind of studied some of them, but we're going to actually name them all now and figure out how they're all different. A parallelogram is a quadrilateral. It has 4 sides. A rhombus is a quadrilateral. It has 4 sides. A trapezoid is a quadrilateral. It has 4 sides. I think that is all we're going to talk about today. We might throw in a kite too. Why not? We can throw in a kite. Now they are all quadrilaterals, but we know, like when we talk about rectangles and squares, they have something that make them different, and that's why there's 2 different names. A rectangle has 4 straight sides with 2 sets of parallel lines. These are parallel and these are parallel. And it has 4 right angles. That's a rectangle. A square is a special kind of rectangle because all of the sides of a square are the same length. It still has the 2 sides that are parallel, and then the other 2 sides are parallel, and all 4 corners are right angles, just like a rectangle. But what makes a square different from a rectangle is with a square, the sides are all the same length. In a rectangle, they don't have to be. These 2 can be one length, these 2 can be another length, okay? So that means all of these other shapes have things about them that make them different from just being called a quadrilateral. There are different types of quadrilaterals. Now, let's take a parallelogram. A parallelogram is a polygon or a 4-sided shape, and it has 2 pairs of parallel lines. So if that's the case, is a square a parallelogram? Does it have 2 pairs of parallel sides? There's 1 pair. There's 2 pairs. It sure does. So a square is a parallelogram. How about a rectangle? It has 1 pair. It has 2 pairs. A rectangle is a parallelogram. Well, so why do we have a special case for a quadrilateral being called a parallelogram if a square is one and a rectangle is one? Remember the definition of a square and a rectangle. 2 sets of parallel lines, 4 right angles. Do parallelograms have to have right angles? No. This is a parallelogram. 1, 2. It has 2 pairs of parallel lines. It does not have to have a right angle. So that's what makes parallelograms different from rectangles and squares. Okay? Now, the next thing I want to talk about is, because we're talking about rectangles and squares, the thing that makes rectangles and squares different are squares, the sides are all the same length. That is the same as a parallelogram and, a rhombus. They are exactly the same. They are shapes that have 2 parallel sides. They don't have to have right angles, but they have to have 2 pairs of parallel sides. If my clue is your rectangle and square are related, just like the rhombus and the parallelogram are related, what do you think the rhombus must have about its sides? What do you think must be true about that kind of parallelogram? Yes, the sides are all the same length. A rhombus has sides all the same. Well, I drew very poor rhombus. The sides of a rhombus are all the same length. It has two pairs of parallel lines, but all of the sides are all the same length. A parallelogram, they don't have to be. It can be, a parallelogram is like a rectangle. It just doesn't have right angles. And a rhombus is like a square, except it doesn't have to have right angles. But they all have to have two pairs of parallel lines. Okay, so we've talked about parallelogram, squares, rhombus, rectangle. What in the world is a trapezoid? I'm going to tell you. All right, here we go. It is also a quadrilateral. And it has parallel lines. But it only has one pair of parallel lines. These lines are parallel. These lines are not parallel. How do I know they're not parallel? Because if I extended these lines, they would cross. And parallel lines will never cross. So these are not parallel lines. These are. Therefore, it makes it a trapezoid. Okay? All right. That's really all your lesson was on today. What I'd like to do is I want you to, on your whiteboard, I'm going to give you a shape. I'm going to tell you what shape I want you to draw and see if you can remember what it looks like when I give you the shape to draw. Okay, I was gonna have you do something else, and I think I will have you. That is what I want you to do. So get your whiteboards out, get them ready. Here you go. I want you to draw a parallelogram. Now, when you draw the parallelogram, I want you to think about what makes it a parallelogram. The name kind of gives it away. And if you've drawn your parallelogram, I want you to draw another parallelogram, but I want you to draw one that doesn't look like the one you just drew. I want you to draw 3 different kinds of parallelograms. Okay? Okay, I drew 4. I drew a square. What is the definition of a parallelogram? 2 parallel sides. 2 pairs of parallel sides. So 1, 2. I drew a rectangle. 1, 2. And I drew a parallelogram. 1, 2. Because a parallelogram has 2 parallel sides. It doesn't have to have right angles. It can, but it doesn't have to. So therefore, all of these are parallelograms. Okay? All right. I would like you to erase that. I want you to draw a rhombus. What is a rhombus? It's also known as a diamond. Maybe that'll give you a little hint. Sometimes it's called a diamond. See if I can get it drawn right. Something like that. It has two pairs of equal sides. I didn't do a very good job of drawing that. Okay, there we go. Two pairs of equal sides, and all the sides have to be the same length. That makes it a rhombus. Kind of like the square and the rectangle. It's a parallelogram, but all of the sides are equal. A rhombus. Okay? And then what about a trapezoid? It only has one set of parallel lines. Okay? All right. So, that is all I have for today. So your lesson is, I need you to work lesson 92 and do the even problems. I believe you shouldn't have any problems with your homework. Let's see, the even problems. I worked through these. I didn't see too much that should give you a big problem. So if you do have a problem, you know what to do. Call me or email me. Happy mathing!